Hey everybody, all of you Lido community stakers, welcome to the second episode of the Community Staker Educational Series featuring the community staking lifeguard slash legend Eridian, who's going to take us through an Obol Validator setup today. Without further ado, let's get started because I have a foreign language lesson after this. Go, go, go.
Okay. Well, hi everyone. Thanks for the intro. Izzy, we'll try and get done in a tight hour, but there's the good thing is the setup isn't too difficult. That's the whole point. It's not supposed to be very, very complicated, but I will be going through some of the details and explaining a lot of it to you just so that everyone understands what's going on in the background, even if the setup itself is quite straightforward. Okay, so hello, welcome to the Obol Validator setup, the CS Education episode 2. So I am Eridian, and I'm the Lido community lifeguard, and I'm a staking enthusiast. So anything to do with staking and getting more people staking from home with machines in their house, that's what I'm interested in doing. And the focus that I've had for the last year has been on DVT, distributed validator technology, to allow more people to do that. It's one of the ways I see that happening. So today we're going to be going through an Obol setup, which is being used in the simple DVT trials for Lido right now. The goal of this being that anyone watching this who is either a participant in the trial or would like to be in future or know someone that would like to be a participant in the next trials, home staker ideally, then this should show them that it's not that difficult. Anyone should be able to do this and they should definitely take part. Okay, so let's get started. Here's the agenda for today, and that QR code is for this presentation, so it will take you to this because on the slides there's just links to some of the useful things that you can use. Yeah. Okay. So we're going to start with the Obol DKG, and we're going to run through a DKG together live on the screen. We're going to talk about some of the config files, the Docker Compose, the envs, and some of the overrides I'm going to be using today. Then we're going to start the operator. We're going to monitor the operator and see how it's going. And then also we're going to look at how to actually exit a validator using Obol, because if you generate a validator with a DKG, then how do you do the exit? So we're going to look at that as well. And then finally, at the end, there'll be an OAT and some more information about how to get involved in those simple DVT trials. Okay, let's jump in. So step one is going to be the Obol DKG. So we're going to go through that now and talk about the setup. There's a few things to do with chain setup that I have in some reference docs that I'll be using. There's the Obol documentation, which talks about how to quick start as a group. And then there's the Holsky Launchpad, which is where we'll do the deposit. And that's all part of the process. So let's get started. So let's jump across here now. It's me working on a dev machine. And we're going to work through this. So starting with the Obol DKG. So Obol can be a two-step process. So essentially, Obol allows you to run distributed key shares. So normally with a validator, you just have the single key that you run on your machine, but with DVT, you can run the validator, you run shards of validator. Think of it like a multi-sig wallet, where let's say there's a 3 out of 4 threshold in a multi-sig wallet. And then when that threshold is reached for a vote, maybe a transaction in a wallet, or in the case of a validator, a duty, attestation, or a block proposal, if 3 out of 4 of you sign for it and say, yes, I agree to this, then it gets published to the network. So what we're going to be doing now is generating those keys in a distributed key generation ceremony, which means that there's the single key never exists. It just, each of the key shares gets created individually. And that can be more secure, and it means that there's no custody issues of that whole key. Okay, so let's get started. We're just going to work through the instructions. There's no custom instructions for this for this workshop other than what's on the presentation. The instructions themselves are all going to be straight from the Obol documentation, because that's what everyone can be using. It's public right now. You can go and test this yourself. And it's very similar to what's being used for the simple DVT workshops. There's a very small number of modifications made for that, but this is the basics. Okay, so to start with, there is an explanation of this in the Obol docs.obol.tech, and it has a creator and leader journey, the operator journey. Those terms can get a bit confusing, but essentially somebody starts it, and is what you're going to see me do now. And then once somebody started it, the other participants can take part. What's nice is that the person that starts it doesn't have to be one of the participants. So you could start it and say to 4 people, hey, this has been set up, you can now run with it. So let's get started. So step one, we're going to connect our wallet. And you can see here, this is just MetaMask wallet. I'm going to be pretending to be 4 people today so I can run the whole DKG. So I'm just going to switch between these wallets, and that's what you'll see me do as we go through. But to start with, I'm starting as this first wallet as the operator. Cool. So if you scroll down here on this holski.launchpad.obol.tech, we're going to create a cluster with a group, and we're going to get started. So reading through some of this information, it talks about how long it's going to take to do this process, about ENRs, and explains what they are. It's like an Ethereum name record or something. It's like a unique number that identifies your node record. There you go, Ethereum node record that identifies your node. So we're going to go through this clicking through to talk about that you understand the risks involved and disclaimers that it's beta software and all that. So we're just going to click through that. This only one person has to do this, the cluster leader. So only one person has to do this in the cluster. So we're going to call this Lido. We're going to call this Lido workshop, and we're going to have a cluster size of 4 with a threshold of 3 out of 4. The threshold is pre-selected, so if you go up, you'll see the threshold changes: 5 out of 7, 6 out of 8, 6 out of 9, 7 out of 10. So the cluster is preset. You can, if you want to, if you do it on the CLI, you can pre-configure this, but in the UI, you can change these numbers, but these are the recommended ones, so that's what it sets them to. Okay, and then we start inputting addresses. So handy, I can be the first operator, so I'm going to use my first address. I'm then going to use the address of account 2 and just paste these in. So what you would do is you would have your cluster, your 4 people that you're going to be running your operator, your validator with. They could be 4 friends or 4 people you're working with, and you would grab their addresses. These are just their public addresses. You never need their private keys or anything like that. It's all trustless in that sense. You just need their public keys, public addresses. Okay, so now we've got the 4 public keys, addresses. We're going to set up one validator today, and it says, what is your current ENR? So I need this to start. So I'm going to go back to here, the operator journey, and it says you need to generate an ENR. Okay, so I'm already stuck on the first step, so let's go through this. So we're going to do, we're going to clone this repo, so it's just copy and paste in this command, and we've got account 1 up here. So we're going to copy and paste this, and I'm going to put dot at the end so it clones it already straight into this repo. And then if we do, we can see that that's just pulled down the repo. So there you go, that's that. So we're going to go into it, and then all you do is run this command. And I'm going to paste it in so we can read it as we go. And it's just docker run. So you need to have Docker pre-installed on the machine. And then run this, run the Obol Network Karen version 18 and create ENR. So we're just going to run that. And because I already have it on this machine, I've already done this before, it won't have to download it again. So it's just going to run it straight away. If you haven't done that before, it will say like downloading Docker image, and then it will start. So this is not me running on my Mac that you can see here. These windows, they're a cloud machine that I'm using for part of this demo that needs to have the required specs to run this. There is some information on like system requirements in the docs as well. So there you go. So I've got an ENR here, and we'll make sure we grab the whole ENR from there. And it's also current ENR private key is where it's actually saved from. So we're going to grab this, and we're going to put this, first of all, we're going to put this against account 1 so we don't lose it. And then we're going to go back to the process and paste our ENR in here. Okay. So we generated it. We need to keep this safe. So you should back this up, and you should also back up this .karen private key file as well, because that's what generates the ENR. Okay, we're going to put some addresses. We can use the principal address. So who's going to get the rewards for this? I'm just going to put myself when the exit happens, and then who gets the fee recipient, the rewards. So this can be done to a splitter contract, or there's various things you can do to distribute these rewards. For now, I'm just going to keep it simple and use my address just so that we can go through this tutorial a bit faster. So cluster configuration, this is the confirmation screen, like the checkout. So Lido workshop, stars 4, 3 out of 4. These are the wallets. You can confirm those and check they all work. They're the right ones. We're going to have one validator at 32 ETH. That's my ENR, and the addresses. Okay, so it's the same. Going through, confirm and sign. So this is a signature, not a transaction. There aren't any transactions apart from submitting the ETH to the beacon chain. There's no transactions, so you don't need ETH in your wallets to do these steps. So if the people involved don't have ETH, as you'll see, my wallets don't have ETH, the other wallets don't have ETH, then you don't need to sign a transaction. So this is just signatures. There you go. So I'm going to sign that's my ENR. So that was signing the different configurations, and this is signing that the ENR is done. So this is the group invite link. So I'm going to just grab this and put this over here a sec, because I need it in a minute. There you go. So the group invite link. So I'm done, but if I go to check operator status now, we'll look and we'll see that I have been completed. So the operator's job is done. Nothing else for me to do, right? But I can't proceed until everyone else is finished. So what we're going to do is go to all the other. So what we will then do is send this page to that link that you got. You'll send that link to everyone else, and they need to connect their wallet. So in my case, I will switch to account 2, for example. And if I switch to account 2 and then go back to the address, it will see that this is highlighted in bold. It's not the easiest thing to see, but now I'm number 2 and I have to get started. Oh, I forgot. You have to do this for each one. So everyone has to do this. Okay, there you go. So now number 2 needs it now. So I'm just going to kind of speed run this now, so that I can go, so I can get all those commands. Oh, I didn't get the Docker command. Okay, so this is account 2. So I'm going to copy that into account 2. And I'm going to grab this command again and put it in here, just so I've got it. And then, yep, so you can see, same again, we're going to do that. We're going to grab the ENR and copy there. You'll notice that it's different to the previous one. They're both unique. And then, yeah, go back to here, paste the NRM. Sign for the ENR. Okay, 2 are done. So I'll just speed run through the others, because then we'll get to actually run the DKG together. So you would send this off, and okay, that reloaded there. So it reloaded there, but then, oh, I think you have to yeah, it reloads it in, but then you have to go through again. This is where we need the background music for. There we go. So so I've got that now. So I'm just going to grab this and run this straight into account 3 now. There you go. So it ran. I just copy and pasted the command together. So I grabbed both and
Great success.
So I'm pasting them in here just to make sure it all works. This is number 3. Check I don't get confused. We're definitely on account 3. And then a few more signatures. Yeah, the soundboard with Twitter soundboard was good. So just going to sign this. There you go. And we see now accepted. There's just one left. So we're going to go to account 4. And then, yeah, grab the link. Oh, okay. Should have to, yeah, make sure the wires connected. And then go through again. Clicking aptitude test. Okay, cool. So final ENR. So we're going to grab it again from here. Going to check we got the right one. Count 4. So we're going to paste it in. Run through again. Grab the ENR. I'll talk through some more in a bit. I just wanted to show you this, even though it seems a bit slow. Things will speed up after this. So we're going to go back to here, paste in the ENR. Sign. So we did it. Okay, so there you go. All four have run. And we can now everyone, each individual person could have kept that screen open or could have kept that link. And when they go to that link, they'll see this. So once it's been accepted, that this would have changed to everybody. And then you get to this step, which is run the DKG. This command now is identical for everyone because the definition file has been uploaded to Obol here. So if we go to there, we can see the definition file, and it's a bit clunky, but essentially it's got all the addresses and the signature confirmations and the timestamps and the number of validators and the threshold and the bigger and like the DKG algorithm and like all the kind of stuff. So this just says like, do you all agree that you're all going to do the same thing? You've all signed for it. So that's what that's saying. So when you come back to here, we're going to grab this, publish, just pushes it back to Obol when it's signed, just not the keys, but just the some configuration that allows them to check that it worked, but it doesn't actually send any keys. The publish just gives them back a bit of like useful data, but doesn't send any keys. Cool. So you notice that there's no ports or anything in this. It's not going to, you don't need any open ports for the DKG to work. It runs through the relay. So now once we're in, make sure we're in the same file. You can see here there's a .karen created. And if we do, if we actually look inside that .karen, we can see that's the private key. We're going to run the DKG. And then once we run the DKG, we'll see that more things appear in this directory. That's what we're trying to do. So let's hope it works. So we're going to run this big command and we're going to hit run. And we can see that let's read through this briefly. So we can see that the Docker image started and it passed the configuration. It uses the DKG starts, and you can see the cluster definition is downloaded. It's got the different peers that we're going to be connecting to, but right now it's waiting for the peers to connect. So it's using this relay, and everyone's going to connect to this relay, this public relay that Obol hosts. You don't have to use the Obol public relay. If you want to use your own, and I've done this, you can set up your own relay and not have any interaction with Obol at all for this entire process. You could do it completely in your own isolated network. Okay, so that's number one. So we're going to come back to here and we're going to run it in account 2, same command, you'll notice. So account 2, and then you see it says this one moved, connected to one of 3 peers, impossible job. You can see your own peer name. Woman. You can see your own peer name in the config. Anyway, so we'll just go through this now. So we'll do number 3, and then you can see everything start to connect. Okay, moment of truth. 4th one. So everyone would do this individually on their own machines. You need to have them running at the same time. So it's not necessarily fully synchronous. You can just leave. So if we're in this state right now, you could just leave this running for a day, 2 days, and the 4th person says, oh, sorry, everyone, I was away for the weekend. I'm back now. I'll run the command as long as everyone still has their terminals running in this state where everyone's got it just running. If you cancel yours and drop out, then that's not too bad, because you can just run the command again and you'll see it pick back up. So even if your connection drops out, as long as the container stays running, you're okay. Okay, so now when everyone's ready, the 4th person runs the command and things start happening. All peers connected, starting DKG ceremony. This is the error is a warning that says it failed to publish, but that's only because everybody tries to publish, and you can see the others successfully pushed. You don't need all of them to do it, just one of them. I don't know why that one failed, but duplicate cluster lock entry. So maybe these succeeded, so that one didn't get to go through. But the important message is the bottom one, successfully completed DKG ceremony. So did it? Well, let's check. So we're going to do what we did again. We're going to do ls-la, we're going to do .karen, and we're going to see what's in there now. Boom. Okay, so there's more things in this directory. We can do the same for all of them as well. We're going to check that the .karen directory has things in it, because it doesn't hurt to check that the keys actually exist and they have things in them. So that's the ENR private key we had before. We've got the cluster lock and the deposit data. The deposit data is what we're going to use to now go and do the deposit. Only one of you needs to do that, but you will get it, because there's nothing insecure about that. Anyone can take that to the network and deposit and upload that deposit file, and then run the validator, fund the validator from there. Okay, so if we look in the validator keys, you'll see it generated one because we only asked it to generate one validator. You could have asked it to generate 100, 500 keys if you wanted to. And what we want to do is want to check that there's actually things in here. So you can see that those files actually have size. So there are keys. And just for fun, we can cat out the validator keys, key store. So we're going to just cat out. You wouldn't normally do this because these then you want to keep these private because if people read these keys, they can then run the keys for you. It's a bit like sharing your validator key, but I'm just showing you for this demo so that you know what you're looking at. This is a key share. It looks like a full key, but it is just a piece of it, and they won't be the same. If we looked at the other ones, they wouldn't be the same. And just to confirm, there's also an identical file that has a .txt, which is the password. And the passwords are all randomly generated for each one. So if you had multiple validators, they'd have a unique password and a unique key. So it's worth checking those to make sure that they exist and they work, and don't share them with anyone because they are yours and they are your secrets. So keep them safe. Okay. That was the DKG. So Obol DKG completed. Success. So what do we do now? Well, now we have to actually run the operator. But if we go back to there's this kind of step missing. Let me just, not step missing, but we need to come back to here. So once you've done that, you'll click continue and you'll get these files, and then you'll click continue and continue and continue to deposit. So we can actually do the deposit straight in here. You don't have to do it on the Ethereum Launchpad, although you could. So you don't have to trust Obol on this page for the transactions or the wallet connection or anything. You can use the normal Launchpad if you want. Just for ease of use, I'm going to cat out I'm just going to grab this from here directly. You'd normally copy it, but I need to create a file on this machine. Sorry, wait a sec. So just needs to have the same name. Let me just put this somewhere. Where do I have two? Okay, that was just a small thing. So anyway, so now we can come to here, and yeah, because I had another one from the other day. There you go. So it's valid because it's deposit data. So we can just click continue and go through there. Sadly, this user, as I said, doesn't have any ETH, but as we've proven, you didn't need that. All the things so far we're done with signatures, so the other 4 accounts didn't need any. This one does have enough to do it, and I think, yeah. There we go. So we've got the balance to do it. It's Holsky, so it's a bit broken, but there we go. So now we can continue. We're going to do 1, testnet ETH, and then this is really important. This check deposit contract address. You should always do it, and then double check it like 4 times, like quadruple check it, and then if you actually do the signature, if it's like on MetaMask or on a ledger or something, you also read the address, the full address, the contract address that you're sending it to straight off to make sure you're not sending 32 ETH to the wrong place. I think that work from here. Yeah, there's a whole thing around like how to do it, but this is the mainnet one, so that's not very helpful. But anyway, there we go. So we're going to do the deposit. This is fun on testnet. I think quite like when you do this on mainnet and deposit multiples of 32 for real. So that was it. You can check it on Etherscan, the whole ski scan, and wait for that to go through. So the validator is now reached the deposit contract. Now, don't panic because validators take a while, 16 plus hours at minimum, to go from that transaction when it succeeds to actually existing. Now we want to see this on the, so if we go back to the deposit data here, we can see the public key. So we can see the public key of the validator we just uploaded. So it's also in the, I think it's also in the data. But anyway, if you go to beacon chain for Holsky, that's a validator that I've got running. I'm going to show that in a minute. But if we go to here and we put the public key in, when we're looking for the validator, we'll see it's not found yet because it hasn't actually gone through. Well, it has now, but it'll pick up shortly, hopefully. And then, yeah, you'll see that it says pending. So there's no pressure right now, no rush. What you could do is have started the operators. The next bit we're going to do is start the operators. You could have done it in reverse order. So you could have started the operators first, had them just sat there saying like, I'm ready to sign this for this validator as soon as it becomes active. And that's actually something that you do. There you go. It's picked it up. 1 minute ago, around 16 to 24 hours, roughly. So, and that's how you can have, say, as I said, this has got one key when we generated one key, but if you generated 100 keys, you could actually then only fund, say, 2 of them, and the other 98 would just sit there, and then you could fund more and more. So it's a nice way of having one DKG and then allowing you to have lots and lots of validators added to it after the fact without having to do the DKG again. All right, so it seems like we've got 16 hours to do the next step. Hopefully we can do it a bit faster than that. So there you go, that's completed, and we'll leave that open, and that's done. So there you go. Now it says go run it. Well, it doesn't actually give you the instructions, but it'd be nice to add a link to the instructions. So now we're here, and we're going to say, well, what do we do next? We just did that, the INR stuff, and we're going to go through. These are screenshots of everything we just did in the docs. Run the DKG, we just saw that. Okay, success. So there, we're at this, no. Yeah, we're at that step plus the operators. So we did the deposit. Okay, step 5. So start your distributed validator node. Now, this is all a complicated way of saying that you just run the command. So let's jump back to here, and I'm just going to walk it through. It's a bit clearer like this. So in the file we downloaded, we've got the .karen, which has got all the private, all the keys in it. Now we need to back those up, and that's really useful to keep safe. That's important. But there's all this other stuff as well. And the Docker Compose file is the important one because that is what contains, that's what we're actually going to be running. So if we look at the Docker Compose now, you'll see it has Geth, which is what's going to be running, and this is all pre-configured. So with Obol, you can just run, and I'll show you Docker Compose up, and it'll just start everything. It will start Geth and Lighthouse. So it'll start Geth with all of those ports set, Lighthouse with everything set. It'll start Karen, which is what actually does the signing. It's the middleware that sits between Lighthouse and the validator client, in this case, Lodestar. So this document's the file's quite nice because it shows you the structure and how Karen sits between the two. And then we also have MEV Boost, which connects to Lighthouse in this case, and then there's some monitoring. Now, if you just run Docker Compose up, all of this will start up and it will just start running. So really, at an absolute minimum, so far, if you were just one of the participants, you would just have had to run the ENR command, paste it in, sign the message, come to here and write Docker Compose up, and that would be it. It would all start working and you'd start a testing. You might need to open some ports depending on your router access and a few other things, but really that is it. Now, it seemed like I did a lot of steps because I did the operator journey, I did the leader journey, but as an operator, it would just be doing the ENR step and then doing the DKG and starting the operator. Cool. So now my setup's a little bit different because I'm running 4 on the same machine, and I don't want to set up 4 Geths and 4 Lighthouse on the same machine. And maybe for mainnet, you might want to if you're staking from home, you wouldn't necessarily want to have multiple mainnet chains for each cluster you're part of. So you can point to, you can edit the config to point to existing configuration. So there's this thing called Docker Compose override, which you use to help with Git conflicts and things. But essentially in the override, you say, well, in that Docker Compose file that I showed you with Geth and Lighthouse and MEV Boost, what do I want to use and what do I not want to use? Now, here I'm going to disable Geth, Lighthouse, and MEV Boost. Now, I'm not really disabling MEV Boost. Like, I'm still using it. It's just it's connected on my Lighthouse, not through this would connect to the Obol Lighthouse. So I'm just going to disable all of these. Just quickly, so yeah, cool. So let me just grab this. So we just need to make sure that and YAML files matter, the spacing matters. So make sure the indentation is done correctly when you paste it in. Otherwise it won't work. So like I said, I'm having to do this 4 times because I'm 4 people, but you can do this with whatever you you only have to do this in the case, like I said, where I'm doing it with separate clients that are already running on this machine. If you want to see how I've got the client set up on this machine, you can look at the docs.eridianalpha.com, and that has all the details of how I've set up the clients. And I will show you that now quickly. So this is a machine that's running right now with Lighthouse and Geth running natively. You can see it running here. This is Geth running, and this is Lighthouse Holsky running. No errors, all looks okay. I'll just jump out of this a sec and just look at the Geth log. Oh no, sorry, I mean Geth config, and we can see here that it looks very similar to what I just showed you, and it's got all the ports open and everything that's needed to be done. Similarly here, you've got the beacon config, and again, this is where you can see it has builder set there. This has got a builder set directly, but this could also be set to only boost. Okay, cool. So go back to beacon, just check the beacon log is okay, and cool. So that's all running now. So now that was step 1, and then the other one is the env. So in the environment variables, I need to change some things. So I need to tell it the network that it's using. If it's not built in, you need to give it a network. So you'll create a .env, and you'll say I'm using Holsky. It defaults to mainnet. The Karen beacon node endpoints. This is because I've just disabled Lighthouse in the Docker config, so I need to tell it, well, which Lighthouse you're using. This is a public endpoint that is open on the internet right now. So anyone that wants to follow along, or this server will stay online for a few more days after this recording. So this endpoint, I think we can paste it into the. I'll paste it into the chat. I think. Wait, actually, isn't it? No, the config files are here. Oh yeah, it is there. Cool. Okay, so it's in the presentation, and you can use that to override and point out, and it will work for this. Okay, the builder API enabled to tell it that you're going to use MU Boost. And then the Karen port, the reason you need this is if you want direct connections, if you want the P2P peer-to-peer connection to happen directly rather than going through like the Obol relay, then you need to have an open port that people can talk into and out of. And I need to set on this directly because I'm 4 people on the same machine. Therefore, you'd get port clash if you didn't change them. So that's why this is set like this. Also, the Grafana monitoring will do that as well. So let me grab these and again do it for each one. So we're going to do that. So 01 for 1, 02 for 2. So are there any questions so far in the chat? I can pause at this point and answer.
There's no questions in the chat.
Okay, great. So it should
You're doing too good a job. Do something weird so we can get some questions.
Okay. Oh no, wait. Careful. 3, 3, and 4, 4. Okay, cool. So now the environment variables are set and the overrides are set. Normally, you wouldn't need so much of this because, like I said, if you just do Docker Compose up, it will just work for most people. This is special config because of the way I'm running it with all these extra things. But you really do just run Docker Compose up and it will start. There's a question around, well, what if I turn my machine off? What if I restart? And I had this question when I started with this as well. So I'm going to look at the Docker Compose file again, the Docker Compose YAML. Everything should have, if you see here, restart unless stopped. So that means that if the container crashes or if you restart the entire machine, everything should have restart unless stopped, restart unless stopped. So what that means is you don't have to worry about the machine restarting or anything happening, or even if you like Control-C out of the command, if you don't run it with -D to detach, if you just run, I'll show you it. We'll get it started now. So I'm just going to show you it directly in the console. So if you run Docker Compose up, it's going to create all those containers, and spam you with loads of Grafana stuff, and we just missed it, but it Lodestar imported one key mixed in with all that other stuff. So we can see now it's kind of waiting and doing some things. So, but if we press Control C to get out of it, it did stop it. So now it's dead, right? Well, hopefully not. So if we follow the logs now, it's back up. So it's a bit clunky, but essentially, like if you start it without -D, you kill it when you cancel it, but then because you didn't do Docker Compose stop, it restarts. Now that's not the nicest way to do it, particularly if it's like Geth and you're like shutting it down and starting it back up. So that's why I prefer to use Docker Compose up -D. So -D starts it detached, which means that I'll just turn it off for you. So Docker Compose down, I want to say is the same as Docker Compose stop. I don't actually know what the difference is, but yeah. So I'm going to run it now, Docker Compose up -D. And you see it started the containers, but didn't start spitting out the logs. And now if you do Docker Compose logs, if you do -F, that's follow. So that will mean that you keep following the logs, and there's way too many logs. So what you can also do is that each of the things in the Docker, each of the services in the Docker Compose file had a name. And the one that we really care about is the one that's called Karen. So you can just write Karen, Docker Compose logs Karen -F, and now we're just reading the Karen logs, which is kind of nice because that's all we really want to know. And then we can see there's a bunch of errors with like relay stuff, but that's not too bad. Peer not connected, peer not connected. Okay, so yeah, so that's it. We can now run the same command. Let me just put this here. So now we're going to run the same command on all four. So we're going to be as if we're starting all four operators separately on separate machines and different houses, different places. And we're going to run this one again, but hopefully as this one starts up, we'll see this one say peer connected. Maybe. Peer connected. Peer connected. So twinkling, it's a bit hard to see in the logs, but when you start, you have your name impossible job, and because this is like locked file loaded, and you can actually see off the logs that you connected to the other one. So that's what you're looking for. It's all a bit hard to see. So how about we look at Grafana instead? So we're going to go over to here, and we're going to let's say 7. Cool. So this is what we just started, and we can see Lido Workshop, which is the name. This is the Grafana dashboard that comes built in. So if you ran Docker Compose up and you had a default, the default port I think is like 15,000, but you can configure that. I've changed it, but you can have it just go to like your machine address if it's exposed publicly or locally or however you've done it. You can then see this information. So great, we've got a nice green beacon node score. We can see that I am Twinkling Woman in this case. That's my peer. I'm connected to Impossible Job, which is what we just saw in the logs. This is just a slightly nicer way of seeing it. There's no direct connection, sad, but don't worry. Direct connections take a few minutes to actually work. So even though the ports are open and everything is configured correctly, that won't turn into a thumbs up for a little bit. You can have it auto refresh like this, and you can actually set auto refresh on Grafana. So this is showing me the last 5 minutes. That's because that's all it's been up for. And you can have it auto refresh every so often, or you can hit the refresh button and see it change. Yay, thumb up. So we are now, we're now working with 2 people, but 2's not enough because the threshold is 3. So we need to go back to here, and we're going to run Docker Compose up -B, start that, and why not just start all of them, because we've got a few more things to get through in this demo. So I like to run all the logs, and I'm just going to run the Karen logs. Peer connected, curious tractor, impossible to run. So you can see that all the peers connected, and hopefully shortly this will update with the connections. It depends. The Prometheus only pushes the logs to Grafana every 30 seconds or something. It's built into the config. If you're interested, you can see the config in prometheus.yaml, and it only scrapes every 30 seconds. So even if I like hammer the refresh button, it won't do anything because it's it only scrapes every 30 seconds. So if it didn't quite catch it in those 30 seconds, it'll just take a bit of time. You can change this if you want, but just to let you know, that's how the defaults work. You can also have remote write tokens. If Obol give you a remote write token, you can send it to here. So you can push metrics centrally to Obol. Again, not anything private. It's just useful for them to know how things are going, how versions work. This dashboard's nice because you can see that hopefully everyone's running similar versions. Boom, there we go. Beacon node score is something that they're working on right now. It depends on how many peers are using it and error rates from the beacon node response and things like that. So it does cause a slight impact to your node effectiveness, but don't worry about it too much right now. Just make sure that you're online and that your latency isn't too high. So this is all on the same machine, so you can see that it's got a direct connection, but when it's on the same machine, the latency will drop significantly because this is round tripping from the Obol relay, and this is on the same machine, so it's a 5 millisecond latency. And that'll drop down now. Okay, so we are online and we are working, and that's it. That's all you have to do. Now the validator won't show up here until it's active, but right now it will, as soon as the validator becomes active, it will pick it up, and you'll see here it will start testing. Now what does that look like? Well, I can show you because I have one that I made earlier, and this is a working one, which is currently testing. It was offline for a while, but it's back. I turned it back on for the demo. That's why it's got such a bad score. And you can see here, it's been a testing. So let's look at those logs and see, because we're also going to exit this validator because it's done a good job. It's done enough. So we can leave this on now. We're going to exit out of this. Okay. So before I get confused, I'm going to jump back out of this and go to Obol account 1. I'm just going to jump into all of these. Logs -f. So this is also running on the same machine. So this machine's got like 8 clusters running on it now. And you can see it's got like 8 nodes running on it. It's got a bunch of different things running, Fanas and Prometheus, but it doesn't have too much of an overhead. This machine's running everything, and it's not that powerful. Cool. So we should see in the Lighthouse logs, we should see attestation included in blocks, so we can see that we are doing something with these nodes, this cluster. Oh, that's the exit. Oh, I already had it open. Oh, okay, I'm confusing myself. Yeah, so you can see here, this is the logs. Sorry, let's make it a bit cleaner. There you go. So anyway, lockout 1 connected. Up. I'm not sure why that's not showing the rest of the logs, but anyway, if I jump back to here, okay, well, let's try and do the exit anyway. So let's jump back to the docs. So we've got the start the operator, which is what you saw. So you got doc up, F Sharon, and down. We've got the logs here. I picked a nice pretty picture where everything was green. This is one that we're using for the Lido trial right now, and this has everything working, and you can see it's all testing fine. Now we're going to exit the validator. So we do have validator running, and I'm going to grab the exit command.
Let's test your Ethereum knowledge a little bit here, Eridian. Can you exit the validator that you just deposited to?
You cannot.
Why is that?
Well, because I tried it, but because well, no, I tried it when I was doing the demo, because you can only exit once it's active, as far as I'm aware.
That's correct, but there's actually a minimum amount of time that a validator is active, after which it can be exited. And the first person to guess it in the chat correctly, I mean, you can look it up if you want to, I will send 50 LDO to. But you have to do it in the next 5 minutes.
Hey, some incentive. Yes, so I hope it's longer than the few days that I started this. So yeah, so the exit command you can see here. I'll just explain the exit command to you as we go through. So oh god, all the answers are coming in. So on this validator that was running before, I'm running this exit command, and this is saying docker exec. So this is saying docker go into this service that's running, this Lodestar service, and inside that service run voluntary exit command, and run the voluntary exit. Tell Karen, so do the voluntary exit. This is the exit epoch, which has to be set. So, and it will have to be the same epoch set for everybody, which is why you can see here. And then tell it the network. And yes, I'm not sure what that's for, but which one that's referring to. So you just run that command. You have to run, these commands are unique for each one, but you run the unique command on each one. So I'm just going to make sure that I don't mess this up. So it's going to be Obol account 2. And we're going to run the command here again. You can see the command runs, and then it says, okay, so what we're looking at when the command runs, it says validator with public key. Oh, how can it be unknown? Well, that's really sad. I'm guessing is the answer is it longer than 2 days?
It's 2048 epochs, which is I think like 9 days.
Well, that's not going to work then. I've been
I've been
ruined.
So tune in 7 more days so we can watch Eridian exit as validators.
It's fine. I can still explain. I can explain everything I was going to explain. It's just this is how it would look, except it would actually succeed. So so that's cool. So if you wait, but that's interesting.
Make the sounds that the validator makes while it's exiting, and then we'll let you go.
So as a question, then why would this say because this is active, so why would it say validator is unknown? If is that just I guess that's just the message until you can exit it. It just says you can't exit.
Is that the brand new one, or is that
no?
This is
977 should be, if I've not messed it up. Oh, it's the old one. It's
the weird thing is that like the client determines what the message says. So if the client has a bad error message, but it shouldn't say that. That doesn't sound right.
No, CCF. So this message is wrong. 977 is the one I've just started, but no. All right. Okay, well that's fine. If it's 9 days, it wouldn't work anyway. So what we're looking at here is when you run these, when you, yeah, because is it? I can actually check it on the chain, but this isn't relevant. Okay, that seems odd. Anyway, it's not important for this. The thing I was trying to show you was when you run the command for the exit, you all have to exit. You will have to run the command, and then the exit message will kind of stay on your node. It doesn't get pushed anywhere, as far as I'm aware at the moment. Obol, we're talking about that. But for now, the message that you sign will stay on your machine, and then everyone will do it. And once a threshold is reached, so once 3 people ran that exit command, it would then aggregate into a full signature and get published to the network. So just be a bit careful with that, because if 2 people exit, sign the signatures, and then this machine restarts, it won't save the signature. So you'll have the situation where like you think you've all signed it, but you signed it and then your machine restarted. So it's just something to be aware of. Like it has to be like 3 concurrent signatures that like within a single online period. And that's how you exit. But apparently, yeah, it's about 9 days as he said. So we'll have to wait for that one. But
yeah, and
we can see.
Congrats to Ivan Petkov in the chat for guessing it correctly.
Yeah.
Also, something that confused me, if you go back to the Obol screen where you deposited the ETH, it says Go ETH, right?
Yeah.
I wish there was a bug bounty. I'd be rich by now.
So there we go. So I think that was everything. So that was the how to exit. And then now we're on to claiming your oats. So that was everything I wanted to go through in the tutorial. That last bit at the end, all of that is documented, how to exit a DV, everything is there. So now there's a chance, some questions. And yes, to say that I was showing like pretty much everything, how to run it on a different machine, how to do a few things. So I'm just going to come off this screen a sec. I'll come back to it. But there's for example, the the EthStaker knowledge base has a section at the very bottom called DVT, and this does explain what I just did, where you have like multiple you can have multiple clients talking to Karen. It talks about the Docker Compose overrides. It talks about the different flags you need. So there is documentation. That's what's linked in the presentation that shows how to do what I just did. But everything else, even exiting the DV here, exit DV is in the Obol docs directly, and you can see all the commands for all the different clients. We use Lodestar, but you can choose what you use. Oh, okay. Yes, skip to the confirmation prompt. Cool. And there's also a final one that I wanted to mention is in this, I think it's advanced or split. You can split an existing key, which means that right now, it's in advanced, guys. Yeah. So this is saying that like we just use a DKG, but if you have a validator key and you say, I want to run this with 4 friends and I don't want to do the DKG, I don't want to exit a validator and restart it. If you have the validator already, you can split the key offline. You can use the CLI tool. And what you do is you use the Karen tool, and then you create this directory with like your key store and your password, these are your validator, key store, and password. And then you just run this command with some versions, some variables set, and it will split the key out like this. And you'll then have essentially a file that says like node 0, which is the .karen, and then you give that node to one person and you hand them out that way. So you can also do it without the DKG. I didn't have time to go through that today because it is a little bit more involved and quite advanced, but just to let you know that is an option. So I'm going to go back to here and then I'm going to read the questions. Okay, can you explain what different metrics mean? Aggregator, attester, prepare aggregator, beacon node score, and how critical are they? Beacon node seems to always going down in % over time. Yes. So the different scores are the duties. So aggregator, attester, prepare aggregator, those are different duties that are being performed by the operator, by the different nodes. If you go to dvt.obol.tech and scroll down, there's some information, and then it says clients, which is useful because you can see like what clients work together, which is kind of cool. We were using Lighthouse and Lodestar, which works really well. And if we scroll down, we can also see successful duties observed on testnet. And this tells you the different duties. You've got attestation, aggregation, block proposal, blinded beacon block proposal, sync committee, and sync committee contribution. And the reason we were using Lodestar is because it has a green tick on all of them. So you can use other clients, it's just they might not be able to perform all the duties. So that's why we're using Lodestar. Now, that score that we saw here, the beacon node score, it's to do with like latency and error rates. So if the beacon node doesn't reply fast enough for some things, like really fast, you get a lower score. And if you are using the same beacon node for lots of things, or it's slightly underpowered, you can get a lower score. But this is being improved all the time in the Lido trials right now. This was like really low for a lot of people, and then Obol made some changes in version 18, which batches the requests to the beacon node, which reduces the load massively. So not only did my CPU usage go down, it also meant that the beacon node score increased, which is great. So that's what we're looking for. I don't know if this is gonna, let's change this. It's gonna work. No, it's all terrible. I don't know. Did I turn them off? I don't know. All right. I don't know why that one was down, but yeah, you can see those scores change over time. And when you perform duties, it'll have like attestation scores. I think I had it actually, the screenshot's probably better. Yeah, here. You can see like 0% errors on this, but there were some other errors on the aggregations, and that's why you can get aggregator scores to be lower and things like that. Okay. Cool. Well, there we are, 55 minutes. And I think we covered everything you need to get started with Obol. So on the right-hand side there, talks about kind of Discord role. One other thing I'll mention is the simple DVT trial that's currently running. It looks just like what you saw. There's some slight differences with the Lido trial, but it's just to do with the Docker Compose. But all the commands, everything you've just seen would be all you need to get started. The DKG, everything is the same. Also, that trial will be running again in January and or early next year. there'll be more information about it. And if you want to get involved, like, please do. I'd recommend it's any solo stakers, anyone that's thinking, could I do that? The answer should be yes. It's not too challenging, as you've just seen, hopefully, compared to solo staking. And if you are already running a machine, if you're running a mainnet machine, then it's very doable. I will also say that I'm running mine on DAppNode just to prove that you can do it. So I'm running mainnet and Holsky on the same machine, and running Obol mainnet and SSV and the Lido trials all on one machine, and it works really well. So don't be put off if you think that it's too complicated or that it's not for you. Like, it definitely is, and this is who it's being aimed at. And these workshops are hopefully showing that it is possible. And if you do have any questions, please join that. Please claim that Lido Discord role and join the channel so that you can ask me and the team questions directly about anything you've seen today or anything you want to know.
Awesome. Thank you so much, Eridian. And for those of you that are watching the recording, I think you'll still be able to claim the oats and the Discord roles for like a little bit of time after the actual live presentation. So try to do so and join the community staking community on the Discord. I'm going to stop the recording now, but if anybody has any questions, feel free to ask them in the Discord, and we'll have Eridian or somebody else from the community staking team help you guys out. Thank you so much, and see you guys on the next episode.